Hello and welcome to this video in the SQL review series where we will examine for the first time multi-table queries. What this means is that we will now query our AdventureWorks 2012 database, but instead of having only one table listed in the from clause, we will start listing multiple tables. At that point, we are in effect creating a join. So we are going to use a common scenario for joining our two tables, a detail and a header table. We will use a common scenario for joining tables, which would be a header table joined with a detail table. AdventureWorks 2012 provides a example of such a relationship in the sales order header and sales order detail tables, both of which are found in the sales schema. So I'm going to leave my select statement empty for now. This will of course not create a valid SQL statement, but I'm going to focus first on the from clause. Now for our statements, it does not matter which table we list first. We could list the sales order header table first or the sales order detail table first. Usually we try to think about which table would be considered the main table. And in a one-to-many relationship, such as between sales order header and sales order detail, we will consider the one side of the relationship to be the main table. So we have sales.salesorderHeader. And we are then going to use the inner join statement. Now there are other types of join statements which we will examine in future videos. And we are going to join the sales order header to the sales order detail table. So you can see here that we now have two table names listed in the from clause, and they are joined together using the join statement. There are ways to list table names in the from clause and separate them by commas, but that is considered the old style of joins and is not as expressive, because we will then have to put the join condition in the where clause. With this modern way of writing the join statement, we are going to create the join condition in the from clause as well. So our table names listed in the from clause stay together with the list of the join conditions, and they are not separated into two separate clauses, as would be the case with the older style of joins where we need to use the where clause for our conditions. We need those conditions because we need to tell SQL Server how those two tables are related. Now you might say that we've already defined relationships between the sales order detail and sales order header tables, which is the case, but SQL Server will allow us the flexibility of not just using the predefined and established relationships between two tables to join them together. So there is no default join condition available, which means that we have to use the on clause to specify the join condition. And we would like to type sales order ID equals sales order ID. From a pseudocode perspective, this is indeed correct. However, you'll notice that SQL Server Management Studio is going to tell us that the columns sales order ID are ambiguous, or at least their names are ambiguous, and that's because both the sales order header table and the sales order detail table have a column with the name sales order ID, and SQL Server cannot tell just based on the column name how we are trying to join them. So the solution for that is to put the complete table name in front of the column name, as in such a case. Now this gets quite lengthy, and as the number of join statements and quite possibly the number of join keys per relationship is going to increase, this becomes very cumbersome. It also makes it harder to read. So what we are going to do is we are going to take advantage of the fact that we can give a table name an alias just like we can give a field name an alias. And we will generally consider using some type of abbreviation. So sales order header could maybe be abbreviated as SH for sales header, and sales order detail could be abbreviated as SD. And instead of now typing in the entire table name, we can use the newly created alias names. So this makes it much shorter and also slightly easier to read. So let's consider the impact of this statement. What we are saying is that we would like to select the rows, and because we do not have a where clause in this table, we are saying that we would like to select all the rows from the sales order header table, join those rows with the sales order detail table where we find a match on the sales order ID value. So in other words, the rows in the sales order header table that have a specific sales order ID will be joined with rows in the sales order detail table with that same sales order ID. And that's of course why the condition reads sales order ID equals sales order ID. In very rare circumstances, we might be attempting to create a join condition with something else than an equal to. But those conditions or those scenarios are very, very rare. If you have a join condition with something else than an equal sign, you should probably reconsider that, because something is very likely wrong with the way you're thinking about joining those two tables together. Now we will only select particular columns from this from these two tables, and we are going to pick the sales order ID as one of them. We will do the sales order detail ID, and then we might choose to do the customer ID, and we might choose to do the order date just as an example. Now once again, SQL Server Management Studio is going to warn us that the sales order ID column by itself is ambiguous, and we must therefore select the particular table name. In this case I'm using the alias again, from which we will get the sales order ID column. And we can now go ahead and execute this statement. And this statement now returns 121,317 rows. So that's quite a large number of rows. And if we want to examine where those rows come from, we can do a count on the sales order header table, and we can do a count on the sales order detail table, and we will see which one has the proper, of course I have to continue to alias both of them. We will see which table has a certain number of rows. And so we see that the number of rows in the sales order header table is 31,461. The number of rows in the detail table is 121,317, which is in effect the same number as we are returning from the joined statement. So it's important to remember that with an inner join we are looking for exact matches on both sides of this relationship. The number of rows that are resulting from an inner join can never be bigger than the number of rows in either one of the tables. So if we have 121,317 rows in the sales order detail table and some lesser number of rows in the sales order header table, as is the case here, our joined statement could never result in more than 121,317 rows. Now, it could result in less than 121,317 rows, which would mean that there are sales order detail rows where we have a sales order ID that does not have a match in the sales order header. That is possible, but in this case not exactly so, because the relationship that's defined between the sales order header and the sales order detail tables requires referential integrity. So theoretically, it is possible for a join statement to result in fewer rows than there are in the child table by itself, but if you have referential integrity turned on and you are joining by the primary and foreign key values, then of course you know this is never going to be possible. Now we will take this a step further, and we are going to join with a third table. And the third table is going to be our customer table. So we are going to continue with the join statements. We are simply going to write another inner join clause inside the from clause. Now you'll notice that sometimes if you use query by example query generators, that they'll start putting parentheses around your conditions or around each of the inner join clauses. 99% of the time that is completely optional. You will not generally need to use parentheses in your from clause. So we are going to now join the result of the previous join with the customer table, which is also found in the sales schema. So we will say inner join on sales.customer. I know I'm going to have to alias this, so I'm going to alias customer as C. And then I'm going to use the on clause, and I'm going to say that I want the customer ID in the customer table to be equal to the customer ID in the sales header table. Now, customer ID, which was previously disambiguous, is now ambiguous, so we are going to say that we want to use the customer ID value from the customer table. Now the question might arise, how do I know that I should use the customer ID from the customer table? And the answer is, if you have an inner join on those keys, it does not matter, as the customer ID in the customer table has to match the customer ID in the sales order table. Our condition specifies that it needs to be the case. I might just as easily put SH for sales order header here as I could C for customer. It does not matter. So we will now add one more column from the customer table. Maybe I will use their account number and execute my query again. Now the question once more might become, how many rows am I expecting this query to return? Well, the number of rows is going to be no more than the greater number of rows in any of my three tables. I suppose it will make logical sense to everyone that the sales order header table is still going to be the table containing the most rows. And indeed, once again, I am returning 121,317 rows in my result set. Again, theoretically, not in this database, but theoretically, my join condition might have reduced the number of rows in the result set. That would be the case if I had sales order header records where we had a customer ID value that did not exist in the customer table. That is theoretical because in this database, once again, we have established referential integrity in our relationship between the sales order header and the customer tables. So it's not possible for there to be a sales order header that references a customer ID that is not found in the customer table. So we know that the number of rows is going to be equal to the number of rows in the largest of the two tables, which is the sales order detail table. Now this is a very interesting type of query selection and provides a solid introduction to inner joins. We have learned to use alias names for our tables. We have learned then to use those alias names to disambiguate the column names, which is likely going to occur both in the join statements as well as in the select statements. And if you had a where clause, you would have to disambiguate it there as well. We've also learned that inner joins can only reduce the number of rows in our result set from the largest number of rows in the largest table, or if you have referential integrity established, as we have in this case, the number of rows should always be the same as the number of rows found in the largest table. In the next SQL review video, we will merge our knowledge of aggregates with our knowledge of inner joins. Thank you very much for watching. See you next time.